This video is going to have a look at true bearings and using true bearings to describe the direction between 2 points. True bearings are measured in the clockwise direction from the north-south line. So if we were to calculate the size of the angle using true bearings, we would start at the north and work our way around till we got to the direction that we were traveling in. So therefore our true bearing measurements will range from 0 up to 360 degrees. When we are writing true bearings, we always use 3 digits when we are writing our angle and finishing it off with degrees and then a capital T. So for example, if the size of the angle we were measuring was 30 degrees, our true bearings would be 030 degrees true north. So remembering if it is under 100 degrees, we need to put the 0 in front. So we are maintaining 3 digits. If our angle size was 260 degrees, we'll write it as 260 degrees true north. So before we have a look at how we can use true bearings to describe the direction between 2 points, it's important to revise one of the angle rules, that is our co-interior angles. So when we have co-interior angles, that means we've got 2 parallel lines and we've got a line intersecting those 2 parallel lines. The angles formed within the shape of our U are going to add up to 180 degrees. So this angle here plus this angle here are going to add up to 180 degrees. So for example, if this angle was 70 degrees, we know the size of our co-interior angle is going to be 110 degrees because these 2 angles need to add up to 180 degrees. This is an important rule to remember because we can use the rule for co-interior angles to help us with our calculations of the true bearings between 2 points. So now let's have a look at a couple of examples of how do we calculate the true bearings of the direction between 2 points. So in the first example, we want to determine the true bearings from town A to town B, and then from town B back to town A. So looking at part A, when we're going from town A to town B, and when we measure our true bearings, we start off with the north line. So starting off with our line pointing to the north, and then we're measuring the size of the angle between the north line and then our direction of travel. And we're doing it in a clockwise direction, and we know that angle is going to be 70 degrees. So from town A to town B, the true bearing in the direction of travel is going to be 070 degrees true north. So now we want to work out the direction, this time starting at town B and working our way towards town A. Now when we're measuring our true bearings, we need to start off with our north aspect line. And here it's not already joined in for us, so we need to go ahead and add it in. So after we add in our north facing line, we can work out where the angle is going to be that we want to determine. And here we're starting at our north line and we are working around till we get to our direction of travel. So our true bearings from town B to town A is going to be the size of this angle. So now we need to calculate what is the size of that angle. And to do that, I can first calculate the size of our co-interior angle inside of our 2 parallel lines that are formed by our 2 north-facing lines. So let's just call that x for the moment. And I know that 70 plus x is going to equal 180. So therefore, x is going to equal to 110 degrees. So I know that this angle in here is going to be 110 degrees. So I can use that 110 degrees now to work out what my true bearing is going to be from town B to town A. And I can do that because I know that in total, my true bearing and my 110 degrees is going to add up to 360. So calling that angle Y for the moment, I know that 110 plus Y is going to equal 360. So Y is going to equal 360 minus 110. So Y is going to equal 250. So my true bearing from town B to town A is going to be 250 degrees true north. So that is an example of how we can calculate the true bearing direction between 2 points. So let's have a look at a second example. In this example, again, we're calculating the true bearing from town A to town B, and then from town B back to town A. So looking at town A to town B, starting out with my line pointing to the north, my true bearing is going to be from that line down to my direction of travel, which is 110 degrees. So the true bearing from town A to town B is going to be 110 degrees. So now I do the same thing for town B to town A. And because my north line is not currently in, the first thing I need to do is to add it in. So once I've added that in, I can work out where my angle is going to be. So the angle that I want to find is going to be from my north line around to my direction of travel. Again, in this example, I can use my co-interior angle rule to work out what my angle is for x. So 110 plus x is going to be 180. So x is going to equal 70 degrees. So my angle in here is going to be 70 degrees, and I can work that out to work out my true bearing measurement. And that is going to be 70 plus my true bearing measurement is going to add up to 360. So calling that measurement y, 70 plus y is equal to 360. So y equals 360 minus 70. So y is going to equal to 290. So the true bearing from town B to town A is 290 degrees true north. So there were a couple of examples of how we can use true bearings to work out the direction between 2 points.